Hello, welcome to episode 175 in the series where I am programming an NES game live on Twitch from scratch. Let's get started. Today, I wanted to talk about two things. Actually, I had originally just wanted to talk about the one, but this came up earlier today, and I started puzzling through it. I figured it'd be worth talking about on stream just because it was interesting and NES development related. And then the other thing is specifically related to Cerulean Ascension, the game that we've been working on. Oh, that didn't help my glasses at all. I had been asked about using different mappers and specifically in NESASM. And I don't use NESASM because it's pretty limited in terms of what it can do. But that said, it can take your assembly code and turn it into a ROM. So it does actually work for what you're trying to do if you're building an NES game. So the question was, how do I take a game, or how do I take code that's running in Mapper 0 and make it work for Mapper 2? Now, if we go back to the NES Wiki for a moment, what we'll see is that the main difference between Mapper 0 and Mapper 2 is the ability to address more storage. I believe that's the major difference. So yeah, so you can see that the capacity for NROM, which is Mapper 0, is either 16 or 32K for the program ROM, and then for the character ROM, it's just 8K. So what that means is if you get into your coding and you're done, and you hit the 32K limit, you're done. You can't, there's no more storage for you to use, and you have to go back and look at where you can optimize your code and potentially your data related to the game. Same thing with this 8K limit. You're done once you hit this limit, right? So there are these other mappers that let you address additional storage by doing all sorts of clever tricks, including Mapper 2, which gives you the ability to address quite a bit more storage, saying 256K to 4 megabytes. But the caveat with that is that it has a ROM window. So what does that mean? So what that means is that when you're working with Mapper 0, right? Here's your memory address space. And with Mapper 0, you have up to 32K of address space, and that is starting at address 8 up to, so you have up to 32K, and that's starting at 8,000 hex and goes all the way to FFFF if you're using all the storage. And what that means is that if you're using, let's do this, 8,000, that's hex 8,000, and this is F, 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 F. So if you're using all 32K, your ROM data, the data that's in your prog ROM, is all accessible in this memory range. If you're just using 16K, then it could be either here, well, it really should be then here in this latter part of the prog ROM starting at C000. And the reason is because for this code to work, there's this section here at the end of your RAM the CPU, or not the RAM, the address space that the CPU goes to, starting at FFFA. When the 6502 powers on, it goes to address FFFA, and there are 6 bytes at the end, and they contain the addresses of, if we go and look at the code here for a moment, it's the address of your NMI routine, the address of the reset routine, and the address of an IRQ routine. So this is 2 bytes. This is 2 bytes. And this is 2 bytes. And so basically the 6502 powers on, it goes to this address, and it looks to see what is the value that is here. And whatever that value is, it sets the program counter to go to it, and then it starts executing the code there. So in code like this, we have this reset label starting at C000, and the reason it starts at C000 is because we have only one 16K bank defined in the code here, in this example that the Nerdy Knights tutorial gives you. And so what is happening is it's called the vector, the last six bytes, you have the address of this reset label is written in, and we'll look at that in a second in the debugger in Messen. It looks at this address and says, oh, I need to go to the address where reset is, and it's going to then start executing this code. Okay, so the part where this becomes tricky with multiple mappers is that they play around with this arrangement of the ROM space and what's available. So like the addresses, I should erase this a little bit here and make this a little more clear that this is an arrow to this, so that it's not confusing with like what the end of the address space is. Right, this is the address space. This is other stuff here we don't want to talk about right now. This is the area that we're referring to for all this stuff. So with mapper 2, the part that doesn't change is this, right? The last 3 words, or the last 6 bytes, have to refer to addresses for the NMI, the reset, and the IRQ. The reset being the most important one right now, because the reset determines where the code goes when the code starts, when the CPU starts. And so the way that the mappers work is they play around with what is actually located in these address ranges, so that you can address more storage in the program. Now, it can't increase this address range because the 6502 only has a 16-bit address scheme. So you can't use 3 bytes to address it or 4 bytes to address it. So this range of 0 to FFFF is the maximum range an address can be. So what it does instead is it says, okay, this is still the same address range, but let's play around with how the ROM data is accessed. And in the case of mapper 2, there is some stuff that it does to allow you to access a lot more storage. So the way that it works is it has a window, and a window is kind of like what it sounds like. You can almost think of it instead of as a window like that's fixed in your house, it's like a window in your car. So as you're driving along, you see different things, and as you move forward and back, you see different things. But the window, there's 2 parts to it. There's a 16K window and a 16K fixed window. And what that means is that there is a range a memory in the address space that is always fixed to one position in the program, and that doesn't ever change. You can't change it. And that begins, in the case of mapper 2, at C000. So this is your fixed bank. And it's 16K. Now, the other part that we can play with is this at 8000. Now this range, 8000 to C0000, or BFFFF technically, this is also 16K. But these are changeable banks. This window here can change. And what that means is if you have in your program a bunch of 16K chunks of data, let's say this is 64K, if you divide that up into 16K windows, right, that's, what is it? That's 4, right? There are 4 16K windows. Here's 32, here's 32, here. So each of these is 16K. And what you're basically doing is through the mapper chip and the circuitry, this address range is wired to this 16K here, right? Should I draw the mapper in some way? Maybe I'll draw the mapper so that you can kind of see how the magic is happening. Right, there's a mapper chip. This is your mapper. Right, it's taking the address requests from the CPU, right, starting at C000 to FFFF, and that's mapping to, this is your, now let's do this, this is your 64K, here is 16K, and then there's also 3 other areas of 16K available, right? So this is the program, which is where your code data lives. So the mapper takes any request that's coming in for reading from address C000 to FFFF, and it's just going straight to this code in the program. Nothing ever changes. No funky business. Nothing too particularly interesting about that part of what's going on. I'm going to shrink this down for reasons that hopefully will become clear in a moment. With this 16K region of address space, though, when the CPU requests additional requests a reading from this range, it goes through the mapper, and the mapper says, okay, this is 8000 to BFFF. So that's the range that I care about for some special functionality. And based on the way the mapper is set at this current time, it could point to here, or it could point to here, or I'm sorry if my color choices are terrible, or it could point to here, right? And each of these becomes addressable by the circuitry that's in this mapper that says, you know, I am requesting an address in this range of 8000 to BFFF. and the mapper says, okay, right now I'm pointing to, we'll call this bank 0, and this is bank 1, and this is bank 2. Okay? And so it's pointing to bank 0, and so it's going to read data from bank 0. Now, you have the ability in your code to tell the mapper, we'll talk about how that happens in a moment, to tell it, hey, I actually don't want this to point to bank 0, I want this to point to bank 1, right? And then what happens is, now further reads to that address range go to here. And what's really nice about it is it's not like you're copying the data where there's a delay or some sort of operational time that has to occur because it's got to copy this into RAM or something like that. It's pretty much instantaneous. Like I'm sure there is some time involved in making that bank switch, but it's pretty instantaneous instantaneous. As soon as the write to the mapper to tell it to swap banks occurs, you'll see the data that's referenced here show up from bank 1. And the same thing with bank 2. Now, the benefit of having a fixed bank is that you can keep all your most important code that needs to be reused by everybody in this fixed bank. And that includes the 6 bytes for the vectoring, right, that we talked about for NMI reset and IRQ, right? Like, so that doesn't actually change here. This points at FFFA to the same thing at the end of address space. So again, because this is fixed and we know which bank has that address range, we know where we want to put these bytes for the address range. If the startup state of the mapper was indeterminate, meaning we don't know which bank is selected at startup, we would have to have some sort of code that, so we'd at the end of every bank we'd have to have reference to a reset subroutine, which would at a minimum set the bank that we want and then actually initialize our code at that point. Hopefully I explained that pretty clearly. I think this is a concept that's a little bit tricky for people because we're dealing with things in a virtual perspective. We're not dealing with these things on actual physical chips and flashing EEPROMs and working with circuit boards. We're just working with emulator files, and so it becomes a little bit confusing, especially because when you're writing your code, each of these banks has to refer to addresses that are only within, and this is critically important, the addresses have to be within this 8000 to C or to BFFF range, because if they're not, then you're going to jump out of this window, out of this changeable bank into some other place like the fixed bank, and that's going to cause unexpected behavior. But it almost seems like, and I've heard other people say this before, and I certainly had the same moment of confusion when looking at the code for the first time of like how this works. You know, it almost makes it seem like you're writing code for the same memory area in this over itself. Like, so when you say that like this code, there's a directive that's in the assembly, this org directive, and you say, you know, org C000 in multiple places, it almost makes it feel like, oh, well, then this code is overwriting this code, which isn't true. You're just telling the assembler this code begins at this address range, and so this reset label will be at C000, and any references to any memory locations, specifically labels, really, will be based off of calculating from this. So where does this get tricky in terms of NESASM? And I'll do a similar rundown on this with CA65 if people are interested. But it seems like a lot of people like to start with NESASM because it's much more simple than CA65. So I don't care either way. Let me know what you want me to do. I can't do it today because I didn't prepare, but I can definitely do it in the next stream. So where does that become a little bit tricky? Well, it becomes tricky because there are a couple of things, right? So the header defines how many 16K prog banks you have, or chunks of prog data. Hey, how's it going, Rob? So that part in and of itself isn't too difficult, right? Like if you want 64K, you just say, okay, I want 4 of these, right? And which is what we did in the Mapper 2 version of this code. The problem is, though, that NESASM doesn't understand. Hey, Brandon, how's it going? Doesn't understand what the bank sizes are at all. It deals with all its code in 8K chunks. So when you're writing your code and you write bank 0, this is an 8K chunk. So if you're saying this is an 8K chunk starting at C000, then it will go from C000 to DFFF. Okay, because 8K added to C000 is A000. So sorry, not A, E000. So if you subtract 1 from that, it's DFFF. So that's the largest range that this bank will be able to access. Now, this is problematic in this example if you want to define your vectors for NMI, reset, and IRQ, because those have to happen at FFFA, right? So what that means is that there has to be an additional bank. So that's exactly what Bunny Boy did when he wrote this. He has this bank 1 that starts at E0, right? And so this goes from E0 to FFFF, which means that he can put the data for the example here, and then when he's done with all of that, he just says, okay, at FFFA, let's put these addresses for the vectors, right? So that's why that's organized this way. Now, going back to the Mapper 2 example, we said we wanted to use 64K of prog data, right? So that's 4 times 16. That gives us our 64K of data. Now, the part of what I was doing, because I was having some trouble understanding this at first when I was messing around with this, was that I defined some known data in every bank, because for me at least, when I look at this, when I was trying to figure this out, having just random data in there, because that's what the emulator loads, makes it really difficult to figure out what's actually going on. There's an additional challenge that Messen didn't want to load the ROM because it detected that there was a problem with the ROM, specifically because I believe it saw that the vector at the end at FFFA was all invalid addresses, and so it didn't want to load it. So for that, I needed to use FCEUX, which, you know, FCEUX is a fine emulator. It does a great job of running games, but the debugging capabilities, as we discovered early on in the series, are just not there compared to Messen. However, in this case, I guess that actually helped, because that meant that I was able to still load the ROM and see what was going on, and determine why the code wasn't loading. And then after I got it working, I understood where I went wrong. So I want to explain where the challenge kind of about. So the challenge came about for me understanding what was going on because of the difference between the way the mapper works in terms of its window of 16K versus what NESASM does, right? So here's our prog ROM that's 64K in total. The mapper splits the address space into two 16K address spaces, and then I can look at any of these with this one being fixed. And the problem becomes that even though these are individually 16K, NESASM can't define banks that are 16K. So really, when you're looking at it from the NESASM perspective, even though you might say like these are 4 banks, NESASM treats it as these are 2 banks each, right? So you have because of its limitation in terms of how big the bank sizes are. Okay, so that means you have bank 0, bank 1, bank 2, bank 3, bank 4, bank 5, bank 6, bank 7, and then there's a final bank, which is really just the character ROM, and that's bank 8. I think I did that right. Let's just make sure I didn't misstate that. Yeah. Yeah, I think it probably confuses a lot of people, right? Like it creates this weird sort of disconnect, especially because like the mapper refers to these as 0, 1, and 2, but then you have way more bank definitions in your code. So the important thing to remember in your code is that the ranges of the banks are always the same. The first part of the bank is always 8000 as the org, the starting point, and then the second part of the bank. So the first part of the mapper bank, which is the first bank, is 8000, and then the second bank, bank 1, which is really just the second half of bank 0, starts at A000 because 2000 in hex is 8K. So let me write that a little more clear because my handwriting sucks. A000, right? And then for the next bank here, bank number 2, that is the first bank of bank number 1 in the mapper, but it again has a range starting at 80, or an address space starting at 8000, and then the second bank, or the second half of bank 1, which is bank 3 in NESASM, is A000, and it just keeps alternating like that, right? Because this is one whole bank, but these are split into 2 banks by NESASM, and we'll demonstrate that in the code in a moment. And then once you're done with bank 6 and 7, or let me rephrase that, all of these banks, because these are the swappable banks, depending on how many swappable banks you have or how much ROM you have, the swappable banks will expand out, and the last 2 banks that you have in your NESASM code will be the fixed bank. So if we added another 16K to this, there would be a bank 3 in between this and the 16K fixed bank. Man, my handwriting is especially bad today. Right, so this is fixed, so there'd be a bank 3, so that would mean that you'd have 6, 7 that would be part of bank 3, and then you'd have an 8 and a 9 that would now be for the fixed bank. So, you know, it's confusing, but just remember the fixed bank is the last bank. It's the last addressable bank that is part of your program, and everything else comes before it. Now, the difference here is that the org directive here has to start at C000 for this half of the bank, and then for the second half of the bank, it is E000. And again, that's because the address space that this mapper is looking for this fixed bank is always starting at C000. All right. So what does that look like in code? So beyond just writing that you have your 4 16K blocks, the first 3 being swappable and the last one being fixed, you have bank 0, which is only 8K, and bank 1, which is another 8K. These are all part of the first bank here. All right. Yeah, I'm pretty sure the 8K banks is a limitation of NESASM. I think that I'm almost 100% positive that CA65, you can define the bank size to be whatever you want it to be. So you would be able to define it as being 16K. So then this is the second bank, again split into 2 parts, both starting once again org 8000, org 8000. So here's the bank. Here are the 2 parts. That's what this is. Same thing with this third one. And then this is our fixed bank. So the fixed bank is the one where all the code got moved. And we have all the code that populates the background and reads the controller and all that other good stuff. And then we have all our data here. And then we have this last bank here, which is again the last 8K of the fixed bank, and we've just basically said the only thing we care about here is the reset. Now, one nice thing about what NESASM can do for you is you can actually see how that works out in your code by using -S, and it'll break down what the usage of each bank is. And again, you'll see they're all 8K. So for each of these banks, we only have a few instructions to identify. We have a few, they're not even instructions. We've just basically, I've written in some control data. I wrote BA for bank, and then it's bank 0, part 0, bank 0, part 1, bank 1, part 0, bank 1, oh, I did it twice here. Bank 1, part 1, bank 2, part 0, bank 2, part 1. So it's just, just meant to identify easily what I'm looking at in these banks and make sure that it's behaving in the way that I expected. That I did it this way on purpose when I was trying to figure this out, because it meant I could look at this and go, oh, that's what it's doing. That makes sense. Or, whoa, wait, that's not what I meant to see at all. And then the last thing is we see at C000, which is the fixed bank, we're using 450 bytes, which are the instructions we're using for the game code. So we use 450 of the 8K. We've got a bunch free there. And then the last thing we have is the vector that's 6 bytes. That's in this last bank 7. And then bank 8 is the character bank, and you can see it's this is misleading. It's showing nothing, but really in that last bank we're including this Mario.chr, which is our PPU data. So I already built this, and if I run this, here's the example, and it's missing some of the data because I believe part of the example is that Bunny Boy wants you to complete the example yourself. There is a sprite that is moving back and forth depending on pressing the A or B button. So this is working. If we look at the debugger, this is where things kind of get interesting. If we go to C000, let's reset the game. We go to C000, we can see here's all our code, right? This is all the code that we wrote at this label reset, right? So SEI, CLD, load X, all this looks good. Not, everything is working the way that we expect it to. And if we go to FFFA, well, actually, let's do that in the memory viewer. You can see that we have 6 bytes here that aren't FF. We have C0A5, C000, and 0000. So the first one is the NMI. If we go to C0A5, this is our NMI code. If we look for the NMI label, the first instruction we have is load A0, and then we do a store into 2003, and then we load 2, and we store into 4014. So you can see that this code corresponds to what's in our NMI instruction. So, and then the second byte, like we were talking about, was C000, which is, what we were looking at before, which is our actual real code. Now, if we go to 8000 in the debugger, it has no idea what this is because there's no real code here. We just put these byte definitions in each of the banks. So we need to look at this in the memory viewer. If we go to 8000, you'll see that it says BA0000. And if we look back, that's this bank here. And if we go to A000, it's BA0001, and then a no-op, which is in fact the instruction EA. That's what that byte is. So you can see we've got the data loaded that we expected it to be. It's not just a random coincidence. This is actually the data that we want. Now, what about all of these other banks, right? Like how come this isn't doing anything? How come we don't see that data? Even though it said, 8000 BA0100, but that's not what we saw. We saw this, right? Well, that's because the mapper has selected at 8000 the first bank that we have in our code here. Okay, so how do we actually make it swap to this second bank? And the answer is it's actually pretty simple. If you look at the instructions, thankfully for this mapper, it's not really complicated. You just write the number of the mapper that you want, the number of the bank that you want to swap to into any address between the 8000 and FFFF range. It doesn't really care which one you use. So basically, we're just going to use 8000 because it's simple. And what we would do is, like, after our code initializes and whatnot, and we know that we're safe to do this, and we think, okay, I need bank number 2 because that has my title screen data or whatever in it. I can load A with 2, and then I can store that into 8000. Now, normally this kind of thing doesn't make sense, right? Because 8000 is a ROM location. If we go back to this, we've got our memory map here, right? 8000 here maps to this address range that this is our prog chip. So we're writing to 8000, like we're writing to the ROM. It's not flashable. So how does that happen? Well, obviously it doesn't. What's happening is the mapper is intercepting that write operation and going, not so fast. You can't actually write to that location, but I know what you want to do, and it looks at the value you're trying to write and will swap between whatever bank it was to the bank that you specified in the value you're writing from the A register. So in this case, we're going to be writing 2. So what we would expect to see is if we go back to our banks, keep in mind that it's indexed, 0 index, this is a 1 index, so 02 is the third, bank 2 is the third element. So what we should see is bank BA0200 and BA0201 once we execute that instruction. So let's go run this. Oops, I ran the ROM before I rebuilt it. Okay, let's go back and reload the ROM. Okay, so what we're really interested in is this point here, and I want to be looking at this memory address location. So if we run up until this point, what you'll see is that A has the value of 2. We haven't done the store into 8,000 yet, so nothing has happened, and so BA00 is still here at 8,000, and A000 still has BA0001, so bank 0 part 1, or the second part, really, because it's 0 indexed. So if we go back to this, when we execute this instruction, you can see this changed. Now it didn't change to just the value 2 here at 8000 like you might expect, because that's what I wrote to, but instead the value became BA0200, and if we go to A0000, however many zeros that is, it's BA0201, which is what we were saying we would expect to see because we're swapping to these banks, right? So now we've swapped to these banks at that address range, and so now this will have whatever code we want it to have. In this case, it's just got this data and a NOP because we were just messing around with this to make it, work for the purposes of testing. But you can see how now we're actually influencing the actual bank that's being selected by the mapper. Can I do this manually in here? I don't think I can. I was wondering if it was possible for me to actually write the value into the ROM and force that to happen, but it doesn't look like it. Anyway, now the game, or it's not a game, the example code is going to continue to run the way it was before, where it's just got this partial load and the controller buttons are controlling that little sprite there. You can see we've got, the character viewer has all the data loaded from Mario.chr as expected. And if we look, the sprite will, move as expected here. One thing we might want to do is revert this back to kind of how Bunny Boy originally wanted it, where the data is separated from the code. And so what we can do is we can move this bank definition, and where is the end of that? Move this here, and the org would be CDE. I think this is, yes, this should be E000. Did I do that right? Let me just make sure. Yep. So that's E000, and so now this data will live in that other bank, and when we go, instead of having the 455 bytes all in C00 to C1C6, when we assemble this, you can see that it became 241 bytes in this bank 6 area and 214 bytes in the E0 to ED5 range, and then we still have our 6 bytes here in the reset vector. So reload the ROM, we shouldn't see anything different from before. Everything loads the way that you expect it to. The sprite is still moving, although it's kind of hard to see because the background is all garbled. But yeah, so nothing has changed there except the organization of the code. And then if you use something like NES size, what is it called? NESSC, which is the size calculator on, if we just look at background.nes, you can see there's just the one 32K prog ROM. Here's your code data. Here's your data that got separated into the separate bank. Is it possible to make this bigger? Oh, get out of here. No. that's fixed. I wanted to zoom into this to make it a little bit easier to see. Let's see. Okay, well, close enough. Close enough for government work. You can see there's just that little bit of data here and a little bit of data here. And here's your character ROM data, which is the mario.car or .chr, however you say it. In the other ROM that we built now for Mapper 2, you can see now we've split everything up into additional banks. Trying to zoom in on this so it's easier to see on stream because it's pretty tiny. You can see there's a tiny little bit of data here that we're defining in each bank. That's just our value that we're putting in there so we can identify it when we're looking at it in the debugger. But this is our fixed bank, and here is the code data. Here is the actual data that's being used for some of the stuff that is populating the background, and then here is our vector data right at the bottom there. But now we've got all of the space to use, and we could, further populate this if we wanted to. We could say, you know what, I want another 16K bank, and so what that would mean is I would have to copy this, make this 6, make this 7. This would be bank 3. And then here's our fixed bank, so this becomes 8, and this becomes, where is it? This becomes 9, and then this becomes, we'll do it in hex 10. That's our ROM, and let's see if I got this right the first time. I think I did. So we've got our additional banks now that we added, and Mapper 2. So that still runs as expected, but if we take a look at it on this, you can see we added one more ProgROM bank, right? So now we have bank 0, bank 1, bank 2, bank 3, our fixed bank at bank 4, and then our character ROM data, just the 8K there. So hopefully that was a clear explanation. I know this has not much to do with the game specifically right now, but figured it was worth talking about this because, again, people seem to be really confused about banking and how it works. And I know this is specific to Mapper number 2, but the concepts apply to everything. And it's also specific to NESASM in terms of the bank sizes, but the concepts are the same. In CA65, let's see if I have it. You can see we have for our code here, right? We have the ability to define things like the character bank here starts at 0, ends at 2000. It's an 8K character bank. We have the ability to define, I've got this ROM here that starts at 8000 and ends at, and the size is this, what is that size? I don't even know what that is off the top of my head. That's 32K. So I'm defining one big 32K bank. But if we look at that in the, and we've looked at this before, but you can see it's divided up into 4 16K banks here. Now I'm using a different mapper type, so the rules are slightly different. So I'm able to do this and define the 132K bank here because that's all I'm using right now. If I needed to use another one, I could define another one, say the same thing. It starts at 8,000, it's this size, etc. And that will, work for the game. In fact, let me see. I think I might actually be doing this. I might be reusing ROM 0. I am for code 1, which I'm not sure I'm using anywhere. Oh, I do have code 1 used for... Oh, I was using this for some testing stuff with these banks. So that was old stuff. But, technically that does actually make use of it and it does work. But anyway, so this is you have to configure. It's different in CA65. You're actually configuring it in this configuration file and laying it out and saying, like, I've got this bank, it's this size, it starts at this location. And then you have these segments in the order in which they need to appear in the ROM. So you've got your 0 page, which is your memory. That doesn't appear in the ROM, obviously, because that's a RAM thing. This is more RAM. This is more RAM. But then for the game, we have our header, and then we have code 0 and code 1. And then after that, we have our vectors, which are at FFFA. Same thing with vectors 1, because depending on which bank you're in, you need one or the other. And then that's it. And then the game gets assembled and all that other stuff works the way it's supposed to, hopefully. Yeah. So if anybody wants me to do an example next time of using Mapper 2 in the same Nerdy Nights tutorial example, I'll do that for CA65. It's pretty much the same thing. The syntax is slightly different, obviously, and you have to define your configuration differently for the assembler. It's not part of this with a fixed bank size. All right. Any questions on that before I move on to the next part of what I want to do here tonight, which will be much shorter, because it's really kind of talking about the idea of what I want to do for the game, and kind of drawing some diagrams to explain it, rather than doing some coding right now, because I don't want to make this one too. I don't want to make this episode too long. I'm still looking for feedback from people. Generally, the people who've been most vocal about what I talked about in my last stream about, doing the live streams for more type of Q&A stuff like this, and kind of catching up with everybody and doing shorter summary videos rather than live streams, so I can code without being live. Generally, people have said that they felt that the 0 pages are invaluable videos for them, and they want more of those. But they also like the live streams because, they like seeing the work happen. They like seeing me work through the problems and stuff like that. But then again, it's a totally different audience, and there were some really great points that were brought up. I'm still looking for what folks think, because again, I'm still trying to determine if it's better for folks to just work more on 0 page episodes and focus on those videos with sort of like progress updates on the game period, weekly, versus live streams of the game updates, so that people can get more out of the learning materials that I'm trying to provide. But let me know if you're on the stream right now and have an opinion that you haven't told me about already, and also if you're watching this recording, comment below, let me know what you think. People have done that as well, from the last video. I'm not seeing any questions related to what I just covered with the banks and bank switching and mappers. So hopefully that was clear. With more complex mappers, there's definitely way more that you need to know in order to use them properly. So if you're using let's see, where's the one I wanted? If you're using, mapper 31, or sorry, mapper 30. Hey, Lunatrek. So I was actually just outlining how mapper 2 on the NES works and how you use it with NESASM, so that, because I got this question and I know people get pretty confused about mappers, so I just wanted to go through the steps of like what's actually involved and what that looks like when you're running it through the debugger. So I was asking if anybody had any questions. And was going to point to another mapper to kind of show a difference here before going into what I want to do for the game design. So yeah, so you might look at like MMC3. MMC3 has a lot more complexity, right? So it has, in the CPU, it has an optional RAM bank. It's got 8K switchable instead of 16K. It's got another 8K switchable. It's got an 8K fixed bank here and another 8K fixed bank here. And, the address range is similar, but it has a lot more granular swapping. Well, let's look at the list here. How many is this across and down? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16. Oh, it is 256. So this is 256 mappers here. I wasn't sure if there were any that were skipped, so that's why I was counting. I just wanted to double check that that was an accurate answer. So there are 256 different mappers that are listed here, but then it looks like with the NES 2.0 header, there's a whole bunch of looks like another 256 mappers available. Are these yeah, so some of these are not used yet in these cases, but like most of these are actually used. When I try to open some ROM games in YYCHR, they have more name tables, sprites, and banks. Are those mappers? Yeah, so what you're actually seeing as a result of the mappers, the ROM file is laid out into whatever chunks make sense for the mapper, whether they're like 8K chunks or whatever, and that includes the character data that you might have. We can actually open up a random ROM and take a look at it. For the purposes of examining here, but depending on the mapper it's using, the organization of the code and the data and stuff like that will be different depending on what the mapper requires when the game is running. So here's Metroid. Let me pause the emulation here for a moment. If we look at the header, this is mapper 1. Where is this? So mapper 1 has 256K or 512K of total capacity with a 16K and 16 fixed or 32K. So it could be either a 16K swappable bank and a fixed bank, or 32 fixed K for the data. So let's see what happens if we load this in YYCHR. I don't know. I have never tried doing this in Metroid. Depending on how the game works, it may do a lot of different things. I mean, at the end of the day, like a mapper for real is, it's a circuit on a PCB, right? That controls how the addressing is done by the CPU to the actual data for the game. So this looks like game data to me. It doesn't look like it's anything visual. Looks like there's some data in here for the game. Here's some clear graphics stuff. Now this is interspersed in stuff that looks like it's code to me. Does this use character RAM? Character capacity 128K, 4K plus 4K or 8K. So looks like what we're seeing is here's the game character data. Let's see if we can match this up with what we're seeing here in YYCHR. Let me see if we can find Samus. There's Samus at the end of the game. Spoilers. There. So this is pretty close to the end. I'm surprised there's as much graphical data as there was, but this looks like most of the data that we're seeing here, or most of the graphics we're seeing here. We're not seeing the 0 through 9, so that might be, they might be using the 4K bank. Looks like that's over here, so it might be using the 4K banking for the PPU. Yeah, so I'm guessing that probably what they're doing is with the mapper, they're messing with the PPU to change the PPU banks that are loaded as they need to. Let's see here. Oh yeah, so you can see like this changed when we started the game, right? So that means they're using 4K banking. In fact, what is it? So there's 4K and 4K or 8. So this is 4K and 4K, and they can swap things in and out. So that's what they did here. They swapped in some additional stuff in the bottom in order to accommodate, I guess, what they're going to need that's different than what the title screen requires. So you can see the rest of the background stuff came in. I don't know if it changes it throughout gameplay at all. There are probably some additional assets that it swaps in by changing this bank as the game runs. But yeah, that's why that's organized this way, because the banks are, can come in and out of the PPU in order to change the assets and have more than what the the 8K limit that the NES PPU normally allows for. I think hopefully that answered your question. And you can see it's got up to 128K, so what does that actually work out to? That's quite a few 4K banks. So 32 separate 4K banks that you can swap around. Yeah, so that's 4K swappable and 4K swappable. And then it looks like MMC1 is configured through a serial port in order to reduce pin count. So CPU is connected to the common shift register, writing a value with bit 7 set to any address, clears the shift register to its initial state, and then to change the registered value, the CPU writes 5 times with its 7 clear, and a bit of the desired value in bit 0. Wow. Okay, so with the other mapper, we loaded the value of the bank that we wanted into the A register, and then we just wrote it to 8,000, and we were good. For this, it's using serial communication between the CPU and the mapper to be more efficient. So you have to write each bit at a time, and what did it say? 5 bytes. 5 bits. You set bit 7 to clear for communication, and then you write 1 bit at a time 5 times to set the bank. So you can see in this code sets the switchable program bank to the value A. So it sets the bit. Let's see. Where is our code here? So store AE000, left shift A. Okay, so A has the value that we want to shift in. And so it's gonna store the value to reset things. Start with the empty shift register. The 1 is used to detect when the shift register has become full. And then it does a shift and a store and a shift and a store. So just writing each and every one of those bits into the mapper to tell it wants to use whatever the value of A is as the program bank. And then let's see. How do you do it for the character bank? MMC1 can do character banks in 4K chunks. Let's see, only one. Fifth, right, the shift register is cleared automatically, so the write to the shift register with bit 7 is not needed. So that's a prog shift. Where... Because of the higher character lines aren't used in MMC1. I'm not sure how to do with the character bank. It doesn't look like... I'm not seeing an example of how that's done here. But it's probably the same basic idea. There's just going to be something else to it for character ROM. Prog meaning PRG, the program ROM. Sorry. It just gets cumbersome to keep saying PRG ROM or program ROM. NROM is the simplest because there is nothing to do. It's just either 16 or 32K and 8K for character capacity, and it gets more complex as you go into the different mappers. It looks like some of these mappers are not actually defined. The ones that have the question blocks are not actually used, so it's not that there are 256, but most of them are, looks like most of them are used for some mapper or another. You know, MMC3 is a pretty well-known one because it's used pretty frequently in sort of more advanced cases, like if you need to know what horizontal line you're drawing on the PPU. We had messed with this for status bar. It has the ability to trigger a bit of code when you reach the horizontal line that you want it to let you run code at, so that you can do stuff like parallax shifting or a status bar where you're swapping between name tables for that purpose, etc. All right. Yeah, if we don't have... let me know if you have any more questions about this, but I'm going to just real quickly talk about the idea that I was kind of floating in my head for the game, and then we'll wrap up here. I'll just push this off to the side in case I need it. So I was watching I had been playing a few shmups, just kind of for research, and then I was also watching some videos that people put together of like best shmups, just because I was curious to know what people consider good, or what people who like shmups actually consider good. And I think their experience is different than mine, because these are people who prefer to play shmups a lot, and I like them, but I'm more of like a action RPG or RPG kind of player, or that kind of style, or even first person shooter. But the reason I chose a shmup is because it's pretty straightforward in terms of like the programming required and the complexity of building the assets and stuff like that. Like, ideally I would have loved to build an RPG, but there's a lot there. There's a lot of story. There's a lot of dialogue. There's a lot of I've heard a lot of great things about Life Force and Dragon Spirit, and then there are a number of other games that the names are escaping. Star Soldier, is that right? E.C. Myers gave me a whole list of games that he suggested I take a look at. He really likes them and had some great suggestions. He actually sent me this awesome Famicom cartridge, which is a compilation of a bunch of Famicom shmups reprogrammed and collected into one cartridge for the Super Famicom. So that was awesome, and I have played that a little bit. And then also I have Heradius, Heradius Zero, and a few others. I like. I've played Gradius. Really like that. And so it's just a really cool genre, and I wanted to find out more about like what people who are really into the genre like, and there were a few things that came up quite frequently. Score being really important, and people talking about the visual aesthetic of it. I think some of that will be limited by what the NES can do, but we'll do our best to make the game look good. And it's not going to be a shmup, I think, that is like super flashy, like a game like if you played Ikaruga, or I'm trying to think of like another more modern shmup, Raiden 5, or any of the like the newer ones where there's a lot of really flashy effects and stuff like that. We can't do that on the NES, but we'll do our best to make it look good. Some things that came up were things like they don't care about story, which is something that I've heard a lot. People just want to skip that stuff, and so while I do intend to have some story to the game, I've mentioned before there will be the ability to play the game while skipping the story, because I know there are going to be people who don't care and literally just want to play until they die and see what the score ends up. Definitely I think the score is something that has come people in the arcades it was maybe a gimmick, but Breadman 812 makes a great point. People really want to have the ability to get scores to kind of compete with one another, and and the score is a way of showing that they've improved because they got a higher score than last time, and leaderboards are important and stuff like that. So that's something that I think I need to really keep take into account. For me, I never really care about the score that I got. I was more interested in making progress, which that's definitely a big part of why people like to play shmups, but the score is like extremely important for people. So that's something I think that needs to be paid careful attention to. The other thing that somebody mentioned was you know, how in particular in bullet hell games. Well, I mean, I've seen speed runs, but I also know that people play, you know, they do like little mini competitions with one another for, you know, games like shmups and other games too, where they are posting what their scores are to, you know, to see who's going to get the higher score to win. So, um, yeah, somebody mentioned in their video that they prefer lower scores in their shmups. Like they don't want them, they want them to be very meaningful scoring systems. They even said that there are some games that do things like give you higher points for uh, killing enemies when you're closer to them versus further away. I mean, I'm with you, Miralupa. I know that there are people who don't care about score, but it's come up multiple times. You know, like I said, I'm not super into scores. I'm more into progression. So I totally get where you're coming from, but it came up in multiple videos that I watched that people who play shmups care about scores. So, you know, I'm not going to be like devoting huge amounts of time and like whiteboarding, you know, mathematical dissertations on scoring in the game, but I definitely want to pay attention to it so that the scores are meaningful and can be um, used to gauge how well you did when you played. You know, whether people pay attention to it or not is their personal preference, and that's fine. But for it's like the story, you know, of the game. The same people who might be interested in the story maybe don't care about the score, and vice versa. Like the people who don't care about the story are more interested in completing the game and seeing what their score is to compete with others. But we'll see. We'll see how. I can't answer that. That's going to be more of like what people actually end up doing while they're playing. Once they actually have their hands on the games. Oh no, I know it all comes from the arcade. But you know, I get the sense that it's still pretty important for people. But the other thing that came up was, you know, people were talking about bullet hell shooters and how there's a lot of memorization and stuff like that, and it gave me this idea of how I might focus on designing levels. So, like, we have our screen, and Lunatrek, I did see your point about the horizontal scrolling. We can talk about that in a minute. But like we've got our screen here, and you know we've got the ship, and the ship is moving forward but can maneuver within the space of the screen, and then we have enemies that are, you know, either kind of floating around and are just going to pass us, or maybe they're a little bit more aggressive and they're going to, you know, kind of traverse a path across the screen that maybe intersects with the player, or, you know, depending on how aggressive it is, it might actually be that if the player is heading in this direction, the enemy is, you know, trying to intercept them directly, or firing some sort of projectile at the player to try and kill the player. And, you know, I had always been aware of shmups having this sort of bullet hell kind of approach where, you know, you have maybe one large enemy or multiple large enemies, and they're putting, you know, bullets out in a specific rate and a specific pattern. And so while there are a lot of them, if you can learn what the pattern is, you can avoid the bullets, because you can see, like in a case like this, you know, if this is our bullet spread, and it's a little bit trickier on the NES. I'm not sure that we're going to be able to do, you know, quite the scale of bullets, and I don't know that I want to, but of like a modern shmup, because, you know, we're limited by what the hardware can accomplish. But like we can see, okay, you know, if this is the pattern that's going on right now, the player needs to be in between here, and then, you know, the enemy might shift, and then the, you know, the secondary pattern emerges. We'll do that with a different color, where Now it is offset differently, so now the player is in trouble when the enemy shifts because the pattern of bullets is shifted, so the player has to move to the right or the left in order to successfully dodge the bullets, all while still trying to fire shots at the enemy to destroy it, right? What's bullet purgatory? Explain that, because I've never heard of that one before. While you type that up, so what I'll explain what I was thinking. And what I was thinking was, like, this actually, somebody said something that really resonated with me, which is like, you need to kind of like figure out what your movement pattern is in order to successfully get out of a jam and not get killed. And like sometimes you have to move in a way that's potentially counterintuitive to avoid being killed, because it's almost like you're moving into harm's way, but that becomes the safe spot or something like that. Oh, I see. Got it. Okay, I wasn't sure if that was an official term or not. Make the background tile the bullets? Yeah, no, you can't. I mean, you really can't. It's he. I asked that in another stream, but for Mirror Loop, it's he. You can't do that with the backgrounds the way we're doing them, because the bullets would have to move at pretty granular. It'd be a pretty chunky movement. Like, you could have something that's a background tile that is fixed in place that's damage inducing, and we do have the ability to define that in the map with the different meta tiles, but for actual free flowing bullets you can't, or at least I don't think you can. So I mean, the other thing we could do, depending on how clever we want to be, is you could reuse sprites and stuff by changing the sprites while the PPU is drawing, but whatever, we don't want to deal with that right now. So the idea that I had was like, what about, well, yeah, okay, fair enough, but that's different than bullets. So that's yes, you can use that. No, don't get discouraged by what I was saying. I wasn't saying it's not possible to do like what you're saying with like colliding with obstacles, barriers, explosive items on the background. That's totally possible to do. So yeah, that's fine. But right now I'm talking about like enemies and their projectiles that they might fire. So I was thinking, it'd be interesting to see if I could design the levels based around the idea of that there is that the level is almost like a puzzle. And it's a puzzle in the sense that there is, you have the player, and you have this kind of like safe zone around the player. And the player has to determine, or not safe zone around the player, there's a safe zone that the player wants to be in to avoid being killed, in terms of like what their movements are going to be. So beyond just shooting the enemies and clearing a path that way, it'd be interesting to do something where the path of one of the paths of victory is that the ship, you kind of design these movement paths, right? Sometimes they might double back on themselves. Sometimes they are simple. Sometimes they are complex. Sometimes they are erratic. But like, you have this sense of we plan the enemy deployment based on this sense of where the player should be moving the ship in order to avoid harm. Now, it changes, obviously, like if if, this path is created by like a wave of enemies come out, and the player, in order not to get killed, has to, and maybe they deploy their bullets starting from left to right, so there's like a wave of bullets fired left to right down the screen. The player needs to go this way and then this way and this way, but they also have the ability, obviously, to fire their weapon to kill the enemies, and so that opens up a gap in the enemy line, and then allows them to maybe take advantage of that in order to get to this spot here, which then allows them for for the next area to kind of traverse this whole looped path here that we're describing. And I had never really thought about shooters, shmups, in a way that looked at the movement, and the idea of movement being a key portion of what you have to know to do in order to be successful in traversing the level. Because the way that I always play is, you remember what enemies come out when, but you naturally start to develop, as a result of memorizing the enemy deployments. Like, you start to develop these habits of where you move the ship, where you move your ship, and how you approach the level to determine, like, to succeed and avoid enemies that might come out over here, or the physical barriers, like you were saying, Brandon. Maybe there's some sort of explosive thing that's here that is part of the background that you don't want to hit. Whatever the case may be. Again, it just occurred to me that I had never really thought about the fact that there could be, you could design the level around not just what enemies you want to place on the map, but how the enemy placement influences the player to move in a specific way. And could you could you set it up so that you could trick the player into, maybe they go this way, but then they accidentally go back over here, and you have an enemy that's in this area that will then kill the player at that point. I'm not talking about specific limitations. Like, I'm not saying that the background, that the game should stop the player from actually moving into those spaces. What I'm saying is that when we design the levels, rather than approaching it from just an enemy placement perspective, also think about the player movement, and, like, are we setting clear paths for escape or not? Are the enemies going to goad the player into making a quick action that's a mistake that causes the ship to be destroyed, or is it not aggressive enough, or too aggressive, and we're not leaving a path of escape open for the player, because it's just not possible to avoid the onslaught of enemies that are placed on the level. Yeah, I mean, level design is tough, and that's why, like, good level designers are I think they're considered to be a valuable resource at most companies, because anybody can just place stuff, right? Like, I can place 3D objects in a space and make it look reasonably good, but a good level designer places things in a way that actually has purpose, right? So Breath of the Wild is a great example of purposeful level design, because it's not just there's a boulder. You know, I mean, sometimes there is. It's just a boulder. But a lot of times it wasn't just like, oh, there's a boulder on the hill here. It's like there's a boulder here, and then below, in the area below, if you paid attention, you'd see enemies that you could then attack with the boulder from far away by pushing it down the hill. Or you could use the boulder to knock down a watchtower, so you could attack. You could strategically go into the enemy camp from the side where the watchtower was knocked out, so that nobody spotted you, so that you can then attack the other sentries and then kill the rest of the moblins or whatever was down there, to steal whatever treasure they have, right? And that takes a lot of play. I think that takes a lot of like forethought and playing around with ideas and having a good sense of like what you want the player to do. I think that's really what it really comes down to, is like, what is your goal for the player in that interaction, in that moment when you're looking at the level? And that was where I was feeling a little bit lost, in all honesty, with like what I want to design the levels to do, because like, okay, we can place whatever we want now, right? We've got tiled, which lets us place whatever tiles we want to place, and we've got the ability to add enemies. I can program whatever enemy I want, but like, how does that make a game, right? Well, yeah, and I'm not saying that that's necessarily the level of openness that I'm going for. I'm just using that as an example that I think most people understand, because they've, a lot of people have played the game, and it's received critical acclaim, and I'm sure people have seen lots of videos of the game being played. And I mean, some of the speed runs that are done in that game, barring like the glitching kind of speed runs, are, take advantage of the fact that it's so open and you can do so many different things in order to save time, and there is an optimal strategy that you can use. And that's kind of what I was thinking here, like, right? Like, this movement path is the optimal strategy that we're trying to design in the level. So how do we turn that into, like, okay, so then what enemies do we need to provide to coax the player into moving in that way to avoid being destroyed? And again, I'm not saying that there's barriers like forcing you so that you can only move in this path, but the idea is, like, with the enemies we're placing and the obstacles on the map, the optimal movement path is this squiggle line, and then that squiggle line, and then a second squiggle back, and then, maybe it's a right and then a left and then a right and then a left, in the same area. And then finally you move forward once you're kind of like at the bottom of the screen, and then you go back to the right. Like that, that was my thinking. Is there value to looking at the level from the perspective of all the enemies are providing an escape route to allow you to make it through doing this, but then you can also destroy them with your weapons. And in some cases it will require you to destroy them with a weapon in order to make it through. And so, that gives us sort of our map of where to start. Versus, like I said, just arbitrarily placing enemies in patterns and zigzags and stuff like that, and being like, okay, that looks good, and playing that and seeing if that's fun. Obviously we're gonna have to play this and see if it's fun too, but like, I want to have direction. I want to have some sense of purposeful placement of these things, so that I can feel like I'm doing something that actually makes sense as a level design, and not just placement of content. Right. Like, it's going to be chaotic, and it's going to feel erratic to people who don't understand the design at first. But as you play, like, how cool would it be to do something? How cool would it be to do something where like you could complete the game without firing your weapon? And so like people will do a zero score, no death, no shot speed run, right? Like I know there are people who play through. I've seen people do things like Castlevania no whip runs or something. Yeah, pacifist speed run, right? Where there is the possibility to do something like that. And maybe a better strategy in terms of scoring is not to do that because like you want to destroy the enemies and stuff like that. But yeah, random dodging. Yeah, I agree. So that's my thought. I think that's where I want to start. At least then I have some sense of like an idea of how I want to approach this, and we'll see if that actually pans out to anything meaningful. I think it will. I mean, it seems like a good starting point, if nothing else, because it I can conceptualize what that might look like. Is that left for the programmer or the? I think a combination of the two, because no matter how good my design skills are, it might be possible that I'm looking at it like this perspective, and a speedrunner sees that like through some fluke of the way that the enemies are placed, that there's a better, clearer path to not only get a better score, but also more quickly make it through by just going over here, or maybe it's like actually you want to hang back for a moment and then you could intersect the line over here and then scoot through and whatever. Like there's gonna be stuff that's undiscovered by me and will be discovered by the people who play, because that's always what happens in pretty much every game. So I'm not trying to account for every possibility, but I want to have a plan at least. Oh, I see what you mean. Yeah, I mean that's a possibility too. I think that might be something that we would add as a a special item or ability or something. One of the things that I had. Well, I don't want to get into that because I don't want to necessarily ruin that right now. So there are some ideas I have around abilities and special items and stuff like that that would be potentially taking something like that into account. I may have said it, but well, yeah, but like at the same time, with the shmup, like how many buttons do you actually need? The ship will be able to move throughout the whole screen, like it is today. So, that doesn't change. It's just gonna be, more sort of purposeful movement in the game. Like, so right now you have the full range where you can literally move to any part of the screen, right? Nothing is stopping me from doing that. I want to kind of keep that as much as possible, except for where it makes sense, in terms of the actual level itself. But, again, my thinking is like the enemy placement and the way that the enemies fire their weapons and maybe some obstacles on the screen will tease out specific ship flight paths that then become optimal paths for completing the level. Yeah, I mean we'll see. I don't really know. That's going to be part of what we have to kind of what I have to design here, because it could be that, part of this is, not accounting, part of this is accounting for like, oh, if you have this special ability, then you can go over here because you can absorb an enemy hit, so you can fly through the line. But you know, if you don't, this is the proper path or whatever. I don't know. That's just a hypothetical. Lunatrek, you want to talk about horizontal scrolling for a minute? Yeah, we can. They can't figure it out and maybe thought the cue is from the audio. I mean, it's possible, but the random number generators that you can do, you know, the extent of which you can even have a random number generator on the NES is pretty limited. I mean, we stole, I say stole, but we borrowed code from the random number generator here in the wiki, you know, and it explains how it works. So if you have the code, it's not like truly random. You would be able to see like how to predict what's going to come next. Yeah, I mean, that's the thing, right? Like back when these games were new, you know, the people writing them knew what they were doing, right? That's an interesting idea. I mean, that would make sense because noise is just random audio data, so that would definitely work. I mean, they probably know the function of the random number generator so that they can, or they can set the seed of it so that they can control what the actual values are. So Lunatrick, I'm not sure what your challenge with scrolling is specifically, but I'm scrolling vertically, but the concept is essentially the same. So if we restart the game here for a moment, so what's happening is I have horizontal mirroring because I'm scrolling vertically. And so I've got my window with the scroll set with the scroll register. My PPU name table has the data loaded for whatever is currently in view. And basically what's happening is as that scroll window advances, I'm loading data slightly in advance of the scroll window into the name table. So if we slow down the emulation here really quite a bit, what you can see is happening is as the game how is this paused? Oh, it's probably paused in the debugger. No, how is this paused? Oh, there we go. As the game is running, I'm updating each row just in advance of the scrolling window so that once the scroll hits that part of the tile memory in the name table, the data has been updated so that part of the map is visible. And what's the reason that I'm using horizontal scrolling is because I want this really, really long name table setup. For horizontal scrolling, you'd want vertical mirroring so that you have the very long horizontal screen, and you'd scroll, you know, left or right, and you'd be updating in advance of the left and right scrolling. You mean vertically? Can only scroll horizontally. Is there something to change in the NES header? Yes. So there's two possible things. In the main header, depending on which mapper you're using, some mappers have it defined in the header. Some mappers actually you can set the mirroring dynamically, which is good, except it gets a little bit tricky. In fact, I think Mega Man does that. If I remember right, Mega Man does that, or Castlevania definitely does, because depending on what kind of section you're in, if you're moving up and down or you're moving left and right, I think they swap the mirroring, but let's look at that here. So in the mapper, so for mapper 0, you have either fixed horizontal or fixed vertical, and they make a note of the fact that it's controlled by a solder pad on an actual board. Well, we can take a look at that as an example. But so with NROM, you're stuck. Like, you've got either one or the other. You can't have both. For mapper 22, which is what I'm using, which is 34. Let's see. Forget what it lets you do. I think it lets you choose it dynamically. So name table mirroring. Oh, it's hard. No, that's the wrong one. Solder pads are selected. So that is hardwire 2. What is the one that I was thinking of that does that allows you to select it at run? Oh, you know what? MMC3 I think lets you set it at runtime. Yeah. So MMC3 does switchable horizontal and vertical mirroring. So you can see that you can set the mirroring by writing to A0, A000, with either bit 0 set to 1 or 0, and that'll swap whatever mirroring you're doing. I thought that there are sections of Castlevania that does change it, but Mega Man for sure. I almost feel like I know I've seen that. Let's we can load up this ROM here. I mean, the title screen would be a good example of where. So that's actually using mapper 1. Let's go take a look at mapper 1 for a second. Mapper 1, where are you? Is this swappable? And it is switchable. So mirror. Okay, so you can set the mirroring as part of the communication with the mapper. You can change it to one screen lower bank, one screen upper bank, vertical or horizontal. So what you'll see in the PPU viewer is as it changes the mirroring. Hi, can I move you? Sorry, give me a second. This is being, there we go. What you'll see is as we change, the name table viewer will actually swap the way it is. Oh, it's because the emulation is so slow. I had it set slow. So you'll see, like, in this section, I wonder if it goes to horizontal. It's doing horizontal mirroring here, right? Like, because it's going to scroll up the building. The sprites are the windows in the building, and what we'll see is that as we're scrolling, okay, yeah, we get the whole story. I just want to see you move up, please. There we go. You can see it's just scrolling up and updating ahead of the scrolling, and that's horizontally mirrored. But I bet there are sections where that changes. So yeah, so now it's vertically mirrored, it looks like. Yeah, so it changed. See, horizontal, it's horizontal, and then you go into the title, into the select screen, now it's vertical. And so, yeah, when you go into a section where it's moving up and down, it becomes horizontal mirroring. And when you're in a section that's moving left and right, it's vertical mirroring. So, but I mean, it's the concept is the same, right? Like as we're moving, it's got the level loaded. It's loading some stuff into the name table to, show that bad guy thing, whatever that air cow thing, whatever the heck that is. And as the window is progressing, on the name table, it's updating more and more of the background. Right? Like we can see that it's actually updating this as we move. It looks like it's doing it several columns at a time as we move. Yeah, so let me just get to this next section here, and we'll see that the vertical mirroring is going to swap, right? I hate these guys. Get out of here. So, I mean, they very carefully construct their levels so that when you get to the end of a section here like this, I forgot about the bird thing because I'm talking. Oh, come on. I normally get those guys before they hit me. So here we're in vertical, and then I'm going to fall, and it's going to switch. Oh, it's still vertical. Okay. I thought for sure it was going to switch to horizontal mirroring, but it looks like they very carefully... Oh, because it does that little pause when you're falling, so they're able to update. Interesting. So, let's see. Let's go to a like... Quick man, I'm not gonna be able to do much here, but there's like a whole section where you're falling. But you know what? Actually, now that I think about it, they probably doesn't need to do, because it does that little pause that you get when you fall down, right? Yeah, so it's not actually doing the change of mirroring that I thought it would in these sections. It's just updating as you hit it. As you hit the bottom of the screen, it updates. That's what that little pause actually is, right? I thought for sure Castlevania... I don't have the ROM for that right now. I don't want to go download it. What about Metroid? Does it swap? It feels like a game that might swap. Right, you want vertical mirroring for horizontal movement and horizontal scrolling for vertical movement. If that it's because you want the name table to be long in the way that you're moving, and so the mirroring is opposite of that. Oh, I'm not gonna be able to... I didn't get the morph ball, so I'm not gonna be able to make it to the section I'm trying to get to. Why can't I reset the game? I'm playing in max speed because Samus moves too slow, and I just want to get to the section that I'm thinking of here. I just don't want to die. Ah! No, don't kill me! Ah, there it did. It switched it. Right? Because now we're moving up and down. Now we're moving up and down this tall corridor. And so now you can see that we're scrolling in the same way, but by swapping the type of mirroring we're doing here. Now, if you want to do eight-way scrolling, that's a lot harder. It generally... you're using like a 4-screen mode, and there's all sorts of weird glitches that happen with the attributes, and it generally looks gross. Yeah, exactly. When you're dealing with the stairs, I'm almost positive. I really want to show it because it's actually pretty interesting. I don't seem to have it here. Sadly, none of these are what I want. So I don't have it handy, but just take my word for it. When you're in sections that are like, especially Castlevania 3, if you're moving up and down like the long, tall areas, it switches the mirroring there because it's the only thing that makes sense for the way that the scrolling would occur, and specifically in the section in Castlevania 3 when you're in the beginning, you're walking, and so it's vertically mirrored and it's horizontally scrolling, and you walk through a door into a room where then you're going up, and that's where it actually swaps over the mirroring. So at that point now you're going to be going up, and so the mirroring got swapped to vertical mirroring so that you have the long name table for scrolling. Sorry, it got swapped to horizontal mirroring so you have the long, tall name table for vertical scrolling. I wonder if Paperboy is using four screen mode. Let's see real quick. Paperboy NES Mapper. Paperboy is using mapper number 3. So it's only using... that's only fixed. I wonder if that's actually right. With vertical mirroring, I guess that could possibly, because of the way that it works, maybe it's something to do with the way that the name table is scrolling and the fact that it's vertically mirrored. Like they can do some sort of trick to update it, in that it's also got that weird diagonal perspective. So yeah, yet another ROM I don't have, because these are just ROMs that I have games that I actually own. So I do own Castlevania 3, but firing up the cartridge doesn't really do us any good, and I don't. Yeah. Anyway, this is a long diversion. So did I answer your question, Lunatrek? You don't know. Well, Rad Racer uses some interesting tricks for the way it sets up the 3D kind of scrolling effect that it does. Mirroring does exactly what it sounds like, so depending on how you set it up, it will... There's only so much RAM for the PPU depending on what kind of mapper it is. And in this case, the default mappers, the default setup for the PPU only has 2 name tables, and they're even though there are 4 name table address regions. And so the mapper, the mirroring determines if it's mapped across or up and down, depending on the setting. Now, you could also, some cartridges and mappers provide additional RAM so that you can actually have a full 4-screen mode, so that each of these 4 name table address regions are unique for four full screens. But that's not as common as just having the mirroring be either horizontal or vertical. The other thing that you can do is just a 1-screen mode where every single one of these is the same screen. Why? I mean, the reason it works this way was to save money. Nintendo only wanted to include so much RAM on the PPU, but they knew that it might be beneficial to allow for 4-screen modes, so they made it possible for the PPU to take advantage of RAM on the cartridge to do that. Let's see, 4-screen NES games. NES games that use 4-screen mirroring. I don't know if Metal Storm does. I don't think it does, but we'll see. Castlevania 3... Really? I'm surprised. I thought for sure that it used horizontal and vertical. This article might... I don't know if this article is right, but we'll see. We can always look at that. I mean, that would make sense that it's MMC5 because that's what Dracula 3 used. Game is doing pretty well. We were talking some design, but now we were talking about scrolling and trying to find games that have 4-screen name table with their mapper, and I don't know any off the top of my head. This person's list, it seems to include a few games, but none that I have to verify with. Who wrote that? I mean, that could be correct. I mean, if you're using 4-screen mode, then it wouldn't really matter if you're using horizontal or vertical mirroring, because you have the longer screen in any direction that you go. I don't think Dragon Warrior does. I think it's complex enough to actually need that. Sadly, like I said, I don't have a ton of ROMs here that I can test this with. I mean, this is Metal Storm. I don't think it uses 4-screen mirroring. I think it's just using... Yeah, so it's just using vertical mirroring. Blaster Master is probably also not using 4-screen. Yeah, it's just using vertical. It does 4-way scrolling. That doesn't mean it has a 4-screen name table. They're two different things. How about RC Pro-Am? Oh, is this is some new fresh hell. Screen B. So this looks like one screen, which doesn't surprise me because of how complex the code is to do the... You know what? This might use 4-screen mirroring. Actually, no, I take that back. It probably just uses... Yeah, no, there's no reason for it because it's not... The board is only 2 screens lengthwise. What about Marble Madness? Let's see if... that's a bad ROM. I forgot about that. I don't know. I don't have any games that use it. Looks like. Yeah, 4-screen scrolling is totally different. Like, you can have non-4-screen games like Mario 3 is a good example of a game that scrolls in 4 different directions. Sadly, I don't have the ROM for that loaded here. But it then... See, this swaps mirroring depending on what kind of stage you're on, right? So it's in horizontal right now. When I hit the bottom, it's going to switch to vertical, right? Because now I'm going along the ground here. So 4-screen scrolling is really about the way that the name table gets updated with the scroll window here. There's no requirement for it to be a 4-screen for using 4-screen a 4-screen name table. It would make it easier because then you actually have a lot of room for the diagonal scrolling, but you can still do it. Like, I think... No, Trophy does the same thing as Mega Man, so that wouldn't work. Yeah, I mean, like I said, I don't have enough games here to test with to like prove it out or even demonstrate. But Guardian Legend, does it do... I don't have... For the walking sections, I'm trying to think. I don't think that goes back and forth. Well, you know what? Blaster Master does 4-way scrolling in the sections where you walk around, right? Oh, no, it doesn't. It doesn't because it's also switching between, I think, the vertical and horizontal for what it's doing because you have to go through the little doors for it to switch to the next room. So I don't think that's going to do it either. I was thinking it's a little bit more... Well, no, there are definitely areas where it's... crap. I'm having a hard time playing because I'm talking at the same time, and I'm also looking at... I didn't have the whole emulator screen available. But there are sections that are like wide open where you can move around in all the directions. It's not just in... Like, I'm thinking of a particular room that's like huge, and you just have all the directions at your disposal here. Let's see if we can make it to one of those sections and see how they're doing it, so we can actually piece together the way they're doing it. Are these guys, let's see, are they switching mirroring? No, so they're not. They're not switching mirroring modes. Get out of here. So they're just updating across the name tables however they need to in order to make it work, right? Like they're not relying on one. Oh, come on, get in there. One or the other. I'm obviously playing like garbage here, so sorry about that. I'm trying to think. I think this has the kind of room layout that I'm thinking of here. That will, but they're just going to do, no. No, it's not. It's in one of the other rooms, but like because they're just using vertical mirroring, they're just going to update like in whatever place they need to in order to make it work. Oh, no. Oh. Oh, no. No. Ah! Damn it. This game is ridiculous. I mean, I love this game, but it is ridiculous. But like in the... Oh, actually, so this does support... Because like when you have the hover, it will actually... Yeah, so you see how it shifts the camera up slightly, right? And now it's updating all of the tiles around where the name table, wherever the scroll window is in the name table, but it never changed the mirroring type. That's what I'm talking about. That's how it does its four-way scrolling. So it's just basically, it knows like wherever the scroll window is, it has to calculate what part of the name table it's got to update, right? So it's a pretty complex way to do it, but then you don't have to have any fancy hardware to support, you know, scrolling or four-way screens or whatever. It just updates, and that's what it's doing for every part of this. Maybe it's this one here. Ah, no. Get out of my way, little box. Ah, yeah, this is what I was thinking of. So, like, look at the way that this updates in the PPU here as I'm walking. It's just purely going in whatever spot I need it to for me to be able to have what I need on the screen. So it's a little bit like this is a complex way of scrolling. I would much rather, like if I had to do this, I would have much rather had a 4-screen layout where I could have the entire area of 4 screens worth of data around me. But because it's using vertical, it's just kind of figuring out where do I need to update in order to make this look right. You can see it's doing it all in real time, in the name table, even diagonally. And I'm sure there are some limitations in like terms of like what they were able to do to make that work. But it's pretty clever. It looks really good, right? So anyway, so barring all of that stuff and what I explained there, Lunatrek, what other questions do you have about scrolling? Because it's, you know, the process is with just purely horizontal and vertical, it's pretty straightforward, and it's the same except for like what part of the name table you're updating. Scrolling with the sprite or the background. How does that work? Well, so scrolling with the background is the sort of most straightforward way to look at this. If we look at the game, well, so when the background is scrolling and the sprite doesn't move, it's because the sprite isn't actually moving, right? We have this overlay here, this rectangle is what the screen shows. And this is the memory for the PPU that it's all the memory. And so as we move this with the scroll register, that changes what the screen is actually focused on in this memory, we're also updating the background. So that's how the background moves. The sprite, though, while it appears to be moving, is not actually moving. Like the position of the sprite in the screen is not doing anything, because because the point is that the ship should look like it's flying over the background. We don't want the ship to be moving independently of the screen, or it'll fly off screen and then player can't see what they're doing. So from a purely XY perspective on the screen, the ship isn't like the sprite isn't doing anything. The sprite is just sitting on the screen. It looks like it's moving because I'm scrolling the background behind it, right? The two are totally independent of one another, which is why then I can also move the ship back and forth, because by doing that I'm adjusting the sprite position, not that has any impact on the background. Now, it might have an impact on the background in, say, like a platformer game where you have like Mario running back and forth, and you have a boundary of some sort where like the sprite, if it reaches a certain position, should cause the background to move. And then what you have to do is you have to compensate for the background movement by shifting the sprite back, kind of like on the screen to the left to offset for the background movement. And that's because like you have this concept of you have to keep track of where you are in the level, and that's like your camera, right? If you think about things in like a real world scenario, if your level is like this diorama of, I don't want to use red, this is a diorama of stuff, and your player is here, and there's a camera that's focused on part of the diorama, and this is what shows up on screen, right? So here's my camera, and it's focused on this screen, or on this section of the level, right? Here's my level. Then as the player moves, we have to say, okay, well, we could just let the player move and they're going to go off screen, and that's no good because then you can't see what you're doing. So what you have to do is you have to move the camera. Well, what does that actually translate to in a 2D game where there is no camera, like in a 3D world? What that translates to is, in the case of the NES, there's something called a scroll register, which offsets what background data it's looking at. So when you look at like the PPU data and you're mirroring vertically, or sorry, you're mirroring horizontally, your level data is loaded into the PPU in your name table, this whole section here, right? That's what's in your name table. And you are telling the scroll register to move to the right, which then moves the background visually to the left. And as you do that, if you have data that isn't loaded here, that's from your level data that you've put together for your game, you have to load that in strips as the scroll register scrolls this way, and your background gets left behind. And then correspondingly, as the sprite is moving to the right, there's going to be some sort of imaginary boundary that you're going to hit. And when you hit that boundary, it's going to cause your camera to want to move to the right. So again, there's no real camera. You're just moving a scroll register, so that moves to this. And if you do that, but don't change the sprite position, it might look weird. It doesn't give the sense of like a constant velocity, because now you're moving the background and the player is like right on the leading edge. Most games have the player kind of shift back a little bit because the background moves a little bit faster than the player, in order to give them, like, if there is a deadly pit over here that the player has to jump over, you want to see that before you get too far and fall down the pit. So the player effectively, it looks like they slow down, or it looks like the background moves faster, but really what you're doing is you're kind of shoving the sprite over a little bit, so that it's not quite as far over, and then you're scrolling that background at a faster rate than the player could move, so that the player will kind of naturally, the alignment will move back towards the center of the screen. so that by the time they get to the pit where they can actually see it, they have no problem jumping over and continuing on to the next part of the level. And on the NES, that's done through manipulating the scroll register, which is a part of the way the PPU draws, so that it only reveals part of what's here. Like, so I only see this stuff here because that's where the scroll register is telling the PPU to render. This stuff is outside of it. This is old data that's no longer relevant, so I can overwrite that with new data, and that's what happens. Once I get to the top of this, it comes back around and I start overwriting it with the new background data from the level that I've got, and it just continues in that process of updating the background as the scrolling is occurring, and the sprite is not moving at all, really. Like, from the perspective of the way that you're quote-unquote modeling what's happening in the game, yes, the ship is moving, right? Like, so I'm moving through this map that I've built here at a constant rate with the ship, right? Like, the ship is moving at a constant rate through this map, but on screen it's not moving at all, because that motion is not important for the player to witness, independent of the background. What's important is that the camera is always fixed on where the player is, and the background behind the player is scrolling beneath the player. Well, it is, like, from a technical perspective it is, but from the perspective of like a real world understanding of what we're trying to simulate, right? What we're simulating is we've got a long map here. I'm back to drawing in red. We've got this long map here, and the ship is moving. So the ship has a position in the world of, some XY position in the world, and we have our view into the world, which is, like we talked about, it's the camera, which really just translates to, what part of this map we see. It's always this little one screen amount of content. But from the perspective of the hardware and the NES and what we're drawing, that translates to we've got a name table, right? The name table stores the background tiles of what we want displayed, and it's mirrored horizontally so that, we only have enough data to have two screens stacked on one another in our scrolling. And so what we have to do is, if we want more than that, we've got to constantly be updating this data. And in the background, we're tracking the player position over the map as if the map was somehow, like this whole real long map, but all we can represent in the NES and in memory in the NES is just this small little portion of it that we're actually drawing on screen. So, I mean, one way to look at this that is simplified and makes it a little bit easier to understand is, let's see, let's go back real quick to our ROMs here. Do this because it's actually a pretty good example, right? So we'll go into the game. I'm going to go to a horizontal section just because it's easier to control it in the way that I want, right? So we're here. Mirroring is vertical now. So I just want to load up enough data that we have. Okay, so this is where, like, the camera is looking at this, or the screen is looking at this section of data, but behind Mario is this stuff, right? So if I move to the left, you can see this is moving back and showing this, you know, some portion of what was there along this, right? But like eventually we run out of stuff that was loaded into here, and we know that we can move back and forth quite a bit further. So Mario moving in terms of like the whole level is moving like I described here, right? But in terms of a sprite on the screen, his motion is pretty limited, right? Like he's basically always in the center of the screen. If you look at the sprite viewer and you select Mario, you can see like there's his sprite, and it's and without the background, it doesn't actually look like he's moving, right? It just looks like he's animating, and stuff is like, other than the up and down for the jumping, right? Like there's not much that's actually happening. Ignore this flipping around stuff that's going on there, but like if you look at this part of the sprites on the screen, like it doesn't look like anything's happening, and it's because his motion is just controlling which way the background is moving. And so by that token, his movement is moving you through the world, but the sprite isn't really going anywhere. It moves up and down, but that's about it, right? And other sprites come and go depending on, you know, if the enemies are alive or dead, or what part of the map you're on, and it needs to spawn another enemy, and so you get a sprite that shows up. So like even those logs, right, that we're drawing, you know, none of those are actually, they're only moving up and down. They're, you know, the left and right movement is because of it being moved relative to Mario. Everything is moving around Mario. It's like the ship in Futurama, if you've ever watched Futurama, where Professor Farnsworth says that the ship can travel so fast because it's not that it's moving through time and space, but rather that time and space is moving around it. It's the same concept. Time and space is moving around Mario, and so everything is shifted according to the way that Mario is moving, and that includes the background. So the sprite is actually moving in a pretty limited fashion compared to what you might expect from the amount of movement that's going on in the game. Hold on a second, guys. I'll be right back. All right. I actually have to wrap here, unfortunately. So, Lunatrek, why don't you message me and we can talk about it more? Because I think we'll have a better time if you can ask some more specific questions, maybe with code examples and stuff like that. I'm going to wrap here. Thanks for watching. If you want to reach me, I'm on Twitter at Clervis. I'm Zelius on Video Game Sage, and Clervis on Discord. You can email me, zelius@gmail.com. That's Xelius. And yeah, and have a good evening. Have a good rest of your weekend. Take care. Bye, everybody.